people had questions on problem number 29 on 1.4, which is, yeah, admittedly a pretty weird problem. So let's take a look at what's going on. They've drawn a circle for you, and I don't know that it's actually relevant, but they do say, yeah, actually it is relevant. They do say that we are dealing with unit circles in these two figures. So that's important to note, that your radius here within your unit circle is always equal to 1, and I think that's where these really weird and ugly decimals come up with these values right here. And what they wanted us to do on 29 is to come up with the value. This is a big problem, you guys, is to come up with the values of sine, cosine, and tangent of theta for the angles corresponding to the 8 points on the unit circle shown in these two figures. So I went ahead and I took the 4 that were drawn in figure A here, and I labeled them A, B, C, and D. And I'm hoping that if I walk you through what happens with A and with B, I think we're going to be good to figure it all out from there. So the first thing we're going to talk about here, everybody, is the sine, cosine, and tangent that happen at A right there. So let's start working on that. Now, what you'll notice is that they gave you the coordinates of this point right here that I'm calling point A. There's your x value, and here's your y value. And the fact that it's a unit circle tells us that the radius is 1. So sine is always just given to us as y over r. Well, at this point right here, our y value is 0.918. And we would divide that by r, but since this is a unit circle with a radius of 1, sine is simply equal to y, and that's it. Cosine is x over r, but in this case, because it's a unit circle, cosine is just x, 0.3965, and that's that. Now, tangent, of course, they had to make difficult right here. Tangent is equal to y over x, so I'm grabbing my calculator now, guys, and I'm typing in 0.918 divided by 0.3965, and that's going to give me this value here of 2.315, and that's it, guys. Those are the trigonometric values here at A. Now, I'm not thinking that that was probably the hard part of this one for you, so we're now going to move on to angle B and talk about the sine and the cosine and the tangent at that angle here as well. Now, the first thing I want to point out, everybody, angle A was a first quadrant angle. And in the first quadrant, all 6 trigonometric ratios are going to be positive. So you'll notice that our answers for sine and cosine and tangent were all positive. But now, as we move on into the second quadrant, and we remember that little mnemonic device of all students take calculus, in the second quadrant, only sine, your y coordinate, is going to be positive. And that means that cosine, which is your x coordinate, and tangent, which is the quotient of y over x, are both going to be negative. But what I know is bothering you guys is the idea here that we don't know the coordinates for point B. Well, yeah, you do. And it has to do with the fact that this is a 90-degree angle right here. What that means, everybody, is that this triangle formed right here within the first quadrant is actually congruent to this triangle right here formed within the second quadrant. Okay, I don't want to spend all day talking about why that is the case, but let me just give you a really simple example. If this A right here was located at, let's say, a 60-degree angle, and you added another 90 to that 60, that gets you to 150. That leaves you a 30-degree angle right here, which is what you had in that spot right there. So the point there is the lengths of the legs in this second triangle are the same as the lengths of the legs in the first triangle, but everything has been flipped around. So our x coordinate at point B is going to be the longer of those two numbers, and it's going to be negative 0 point, and the longer number is still going to be 0.918. The y coordinate is positive, but the shorter number, 0.3965. And with that in mind, I think the rest of this is going to be pretty easy. The sine of B is your y coordinate, 0.3965. The cosine of B is your x coordinate, negative 0.918. Tangent is just a little bit difficult. We've got to take y divided by x, or sine divided by cosine. So I'm typing in 0.3965 divided by negative 0.918. And that gets me a decimal here that is negative 0.432. And those are your answers then for angle B. Now, I would be remiss if I didn't point this out. Angle A and angle B, since they're 90 degrees apart, are going to be, let's see if we can get this right, they're going to end up being complements of one another. And that means, everybody, that the sine of angle A is the same as the cosine of angle B. The cosine of angle A is the sine of angle B, and their tangent values are reciprocals of one another. All right, that's an important one to take right there, at least numerically. In fact, if I did 1 divided by the 2.315 that I came up with for the tangent of A, it's not going to work out exactly because I rounded, but yeah, I got 0.432. There's your value right there. So as you move on to point C right here, I think we know that this triangle here that I'm drawing in yellow is once again congruent to the others, so you just have to think about your X and your Y coordinates. First of all, we're in the third quadrant where both X and Y are going to be negative. Your X coordinate right here is the shorter leg from the first triangle, so that's now negative 0.3965. And your Y coordinate right here is negative, but it's the same value as this longer one here, 0.918. And I think from there, you guys can figure out sine, cosine, and tangent. And then when you get to D, now we're talking about this triangle right here, and I think we can use those same things. So I got news for you. The values that we've come up with right here are going to be the same values you're going to get for all of the rest of your answers. The only other difficult thing going on is that they really should have broken this up into 2 questions, but they didn't. There's also a second diagram here, and in the second diagram, there's this diameter, more or less, that goes here to give you a point here and a point here as well. And the key to, and by the way, these coordinates are the same then. The key here now, guys, is that if I make a triangle out of this point in the second quadrant right here, what's going on? As we compare that, let me call that point E, to this point right over here, which is point A, the X coordinates look like they're just going to be the opposites of one another. So point E looks like it's going to have an X coordinate of negative 0.3965. But the Y coordinates at E and A look like they're exactly the same, of 0.918. Okay, so once you've established what X and Y are, you're going to be fine, I think, coming up with sine, cosine, and tangent. They've given you another point down here I'll call F, which actually looks identical to point C. So I don't think that's any extra work. There's another point down here. I didn't draw this terribly well. What am I calling that? You have G or whatever you want to call it. And that one, I think we're going to apply some of the same tricks. That one is just directly below point A. So that's how you're supposed to knock out 29. It's a pain in the butt. There's 8 points. You got to come up with 3 answers to each one. So there's 24 different answers here, but that's the way we get those. Okay. Good luck, everybody. Check the